Unit 8. Air, Water and Weather. Our Earth is surrounded by a thick layer of air up to few thousand kilometers. Air is found all around us. The layer of air which surrounds the Earth is known as the atmosphere. Air is all around us. Composition of air. Air is a mixture of gases like oxygen, nitrogen, carbon dioxide, water vapor, and dust particles. The main gases present in air are nitrogen 78% and oxygen 21%. In addition, it contains small amount of water vapor and some other gases. The air also contains dust particles. The percentage of dust, smoke, and water vapor may vary from time to time. Water vapor as moisture in the air is due to the evaporation of water from the surface of lakes, rivers, and seas. The amount of water vapor in the air is called humidity. Water vapor in the atmosphere condenses to form clouds, rain, and snow. Evaporation of water. Air is essential for breathing. Air is breath of life to every living being, animals, plants, and human beings. The air which we breathe in contains oxygen. Fishes and other animals which live in water get oxygen dissolved in water. When we breathe, air is taken in. Lungs. The blood in the lungs picks up oxygen from the air. The oxygen combined with food gives energy. Due to burning of food, carbon dioxide is produced. It is breathed out from the body. 1. The air we breathe in is called inhaled air. 2. The air we breathe out is called exhaled air. The exhaled air is warmer and more moist than the inhaled air. Human lungs. Aquarium. Respiration. The process of breathing in oxygen to burn food in the tissues to give energy and breathing out carbon dioxide is called respiration. Composition of inhaled air. Nitrogen 79%, oxygen 20%, carbon dioxide 0.03%, water vapor variable, temperature variable. Composition of exhaled air. Nitrogen 79%, oxygen 16%, carbon dioxide 4.5%, water vapor saturated, temperature the same as that of the body. Plants, in addition to respiration, carry on the process of food preparation with the help of energy from sunlight. Sources of oxygen. Green plants release oxygen in the process of photosynthesis. It mixes with air. So more oxygen is present near the green plants. Preparation of oxygen. We know that more oxygen is available near the green plants. Let us prepare the oxygen in the laboratory. Activity. Take a pinch of potassium nitrate in a test tube. Heat it with a spirit lamp. Put a burning matchstick at the mouth of the test tube. The matchstick burns with a bright flame because oxygen is evolved on heating potassium nitrate. Preparation of oxygen in the laboratory. Oxygen helps in burning. Burning, combustion, also needs oxygen. Nothing can burn without oxygen. Activity. 1. Take 2 candles and light them. 2. Cover one candle with a big glass. The glass should not touch the flame. 3. After some time, you will observe that the flame of the candle, which is covered with glass, goes off. The other candle continues burning. Why does the candle in the glass stop burning? The candle in the glass stops burning because there is no oxygen left in it. The other candle continues burning because it gets oxygen from the air. This shows that oxygen is necessary for burning. Thus, oxygen helps in combustion. Air contains gases. Air is a mixture of gases. It contains many gases which are useful to plants, animals, and to man. The gases present in air are 1. Nitrogen, 2. Oxygen, 3. Carbon dioxide, and 4. Water vapor. 1. Oxygen helps in burning. It is called active part. 2. Nitrogen does not help in burning. It is called inactive part. Activity. 1. Take a trough of water. Mark the water level in the trough. 2. Fix a candle in the center of the trough and light it. 3. Cover the candle quickly with a bell jar. We observe. 4. After a few minutes, the flame of the candle goes off. The candle burns till it consumes the oxygen present in the bell jar. Its place is occupied by water that rises by 1/5 of the jar. This experiment shows that only 1/5 part of air is used in burning. This oxygen is considered as active part of air. The remaining 4/5 part of air is mainly nitrogen. It is called inactive part. To show that only 1/5 part of air is used in burning. Some other properties of air. Air is used to inflate things. Air occupies space. Air is used to inflate things. Since air can occupy space, it can be filled into balloons, bladders, tires, etc. When we blow air into balloon, it grows in size and inflated. We fill air in a basket or volleyball with the help of a hand pump. It becomes inflated and becomes hard. This property of air is very useful for inflating tires of cycles, scooters, trucks, and other vehicles. Air has weight. Activity 1. Take a thin, long stick about 1 meter long. 2. Tie a string at its center. Take 2 balloons of equal size. 3. Blow up both the balloons with air so that both of them are of equal size. 4. Tie the balloons at the bottom ends of the stick with strings of equal size. 5. Hold it in your hand and move one of the balloons along the stick till it balanced. Take a sharp pin and prick one of the balloons. We will see that air escapes from it slowly. Now the stick does not remain balanced. The side of stick with inflated balloon tilts down and the other end goes up. This shows that air has weight. Air exerts pressure. We know that air occupies space and has weight. Anything which has weight exerts pressure. So, air also exerts pressure. Activity 1. Take a glass and fill it with water up to the brim. 2. Place a thin, smooth piece of cardboard on top of the glass. 3. See that there is no air bubble or space between water space and cardboard piece. 4. Hold the cardboard with one hand and turn the glass upside down. 5. Remove your hand gently from the cardboard. You will see that cardboard piece and water do not fall. 6. It is the pressure of air that prevents the cardboard and water from falling. In this case, the air pressure acts upwards. To show that air exerts pressure. Air pressure in daily life. 1. You must have seen medicine dropper. Take a medicine dropper and dip its tip into some medicine. Press the rubber bulb. 2. When we press the bulb, the air inside the tube is forced out. When we release the bulb, the pressure inside the tube becomes less, but pressure of air outside it is more. So, largest pressure of air outside pushes the medicine into the glass tube of the dropper. The same process occurs when we fill ink in a fountain pen. Filling medicines in syringe. Doctors use syringe for injection. The medicine in the syringe is also filled due to air pressure. When we push the piston of the syringe, inside air is pushed out through the narrow hole in the needle. When we put the needle in the liquid medicine and pull the handle outside, air pressure pushes the medicine into the syringe. Air pressure helps in filling medicines into syringe. Air pressure helps in drinking with a straw. We drink coconut water, cool drink with the help of a straw. This is also based on the air pressure. When we suck up a straw, we swallow some of the air from the straw. This makes the pressure of air inside the straw less than the pressure of air outside. So, the air outside pushes the cool drink into the straw. Air pressure helps in drinking. Working of common lift pump or hand pump. A common lift pump works on the same principle as the drinking straw and fountain pen. Air pressure helps in the working of hand pump. Piston spout, handle, cylinder, piston valve, foot valve, water. When the piston in the pump moves up, the pressure inside the pump is reduced and the valve at the bottom opens to allow water to rush above the valve. In this way, by repeated strokes of the piston, water is drawn up from the well. Water we drink. Water is very important to all living beings. You know that without water there cannot be life on earth. We need water for drinking, to prepare food, and for cleaning clothes. Water covers over 70% of the earth's surface. Water is a good solvent. Take a glass and fill it with water. Add a teaspoon of sugar to it and stir well. Taste a little of water. Pour this through a piece of clean cloth into another vessel. This is called filtration. Separation of soluble substances from water. 1. Evaporation. 2. Distillation. 1. Pour salt water in an evaporating dish and heat it till all the water evaporates. You will find that salt has settled at the bottom of the dish. 2. When we separate a soluble substance from water by the method of evaporation, the water is converted into water vapor and escapes in the air while the dissolved substance remains behind in the dish. If we use the method of distillation, we can collect the water vapor also and change it back into water by cooling. Distillation is a very good method of purifying water. Evaporation. Insoluble substances in water. There are many substances which do not dissolve in water. These include pieces of stone, sand, chalk, and many kinds of disease germs. Substances which dissolve in water are called soluble, and those do not dissolve in water are called insoluble substances. Two ways of separating insoluble substances from water are there. 1. Sedimentation. Stir a handful of mud powder in a glass jar of water. Allow the mixture to stand for some time. You will find particles of the soil settling down at the bottom. All the particles have settled down at the bottom. Clear water will be seen at the top and can be carefully poured off into another vessel. The settled particles of the soil are called sediments. 2. Filtration. In this method, water containing insoluble substances is poured into a funnel having a cone of filter paper. You will find the insoluble substances caught in the filter paper and clear water collected in the vessel kept under the funnel. This clear water is called filtrate. Disease germs. Water contains many disease germs like bacteria, protozoa, and viruses. These produce serious diseases in man and other animals. So, we must take suitable steps to keep them out of water. 1. Drinking water should come from a clean source like the water works in a town. Here, the water is purified by using chemicals like chlorine, which kills all germs. 2. If we have to drink water from a well, it should be purified by adding potassium permanganate. 3. Boiled water is safe for drinking. 4. Water container should be properly covered. Water pressure. Water has weight. It exerts pressure because of its weight. This pressure is called water pressure. Activity. Take a Coke tin in your hand. Pour some water in it. Keep it in your hand. There is a difference in weight. This extra weight you feel is due to the water in the tin. Activity. To understand the water pressure, do this activity. Make a hole to a tin. Close the hole with your finger and fill it with water. Open the hole and observe. The water comes out as a jet with great force through the hole. The pressure exerted by water causes a forced jet of water from the container. This pressure is called water pressure. To show that water exerts pressure, let's revise the important points. 1. The thick layer of air surrounding Earth is called atmosphere. 2. Air is a mixture of many gases. Nitrogen 78% and oxygen 21% are two main gases present in air. 3. Air is essential for breathing. 4. All living beings take in oxygen and give out carbon dioxide during respiration. The plants take in carbon dioxide from the air and give out oxygen. 5. Oxygen helps in burning. 6. 1. Air occupies space. 2. Air has weight. 3. Air exerts pressure. Do these. 1. Answer the following questions. Conceptual understanding. 1. Name 4 gases present in air. Answer. The gases present in the air are 1. Nitrogen, 2. Oxygen, 3. Carbon dioxide, and 4. Water vapor. 2. Why do all living things need oxygen? Answer. Air is breath of life to every living being. The air we breathe contains oxygen. All living things take in oxygen and give out carbon dioxide during respiration. The plants take in carbon dioxide from the air and give out oxygen. That's why all living things need oxygen. 3. In what ways do we make use of air pressure? Answer. Air pressure helps in filling medicines into syringe, in drinking with a straw, and in the working of common lift pump or hand pump. 4. How can we separate dissolved substances from water? Answer. We can separate the soluble dissolved substances from water by evaporation and distillation. Pour salt water in an evaporating dish and heat it. During evaporation, the water is converted into water vapor and escapes into the air, while the dissolved substance, salt, remains behind in the dish. If we use the method of distillation, we can collect the water vapor also and change it back into water by cooling. 5. Name 5 things that dissolve in water. Answer. 1. Sugar, 2. Salt, 3. Chlorine, 4. Soda gas, 5. Potassium permanganate. 6. Why should our drinking water be made clean and pure? Answer. Water contains many disease germs like bacteria, protozoa, and viruses. These produce serious diseases in man and other animals. So, water should be made clean and pure before drinking. 7. In what ways is exhaled air different from inhaled air? Answer. The air we breathe in is called inhaled air. The air we breathe out is called exhaled air. The exhaled air is warmer and more moist than the inhaled air. The inhaled air, oxygen, is more than the exhaled air. The inhaled air, carbon dioxide, is less than in the exhaled air. 8. How will you separate insoluble substances from water? Answer. 2 ways of separating insoluble substances from water are there. They are 1. Sedimentation. Stir a handful of mud powder in a glass jar of water. Allow the mixture to stand for some time. Particles of the soil settle down at the bottom. The settled particles of the soil are called sediment. 2. Filtration. In this method, water containing insoluble substances is poured into a funnel having a cone of filter paper. The insoluble substances are caught in the filter paper and clear water is collected in the vessel kept under the funnel. This clear water is called filtrate. 2. In the following sentences, cross out the wrong word. Conceptual understanding. See project work. 1. Ask the students to show that air pressure also forces liquid through a siphon. 2. Ask the students to make a fountain of their own. 3. Ask the students to tie a blow-up balloon to a plastic pipe and release the thread tied to the balloon. Observe what happens. 4. Ask the students to make their own syringe chrome. 5. Ask the students to make their own pressure car as follows. 1. Tie a balloon to a toy car. 2. Release the mouth of the balloon. 3. Car moves after releasing the mouth of the balloon.